In this segment, we're going to talk about solar eclipses. A solar eclipse is an event that occurs when the moon passes directly between the Earth and the sun, blocking your view of the sun. From your vantage point on the Earth, looking up in the sky during a solar eclipse, the moon is to the right of the sun and is coming from the right, crossing into the sun. About a minute later, you start to see that moon crossing from the right side and over the surface of the moon from your point of view. Another minute or so later, more of the sun is being covered by the moon, until finally most of the sun, if not all of the sun, is covered. And then over the next several minutes, the moon would pass from the right to the left, and it would uncover the sun, until finally you are back seeing the entire sun shape again in the sky. The entire event lasts only about 10 minutes or so. If the moon almost nearly entirely covers the sun, or completely covers the sun, we call that a total solar eclipse. If, however, the moon doesn't cover the sun completely, and you see this ring around the outside, or an annulus, then we would call this an annular eclipse. Sometimes you don't see the entire sun being covered. A good portion of one side of it is uncovered. You would then be calling this a partial solar eclipse. And so although a solar eclipse is an event that occurs when the moon passes directly between the Earth and the sun, blocking your view of the sun, an annular eclipse is a type of solar eclipse. And it's a type of solar eclipse in which the sun's photosphere is seen around the edge of the moon in a bright ring or annulus. And what we mean by photosphere is the bright visible surface of the sun. So from your point of view, looking up in the sky, you might see the yellow portion, or if it was low in the sky, you would see a red sun. Another type of solar eclipse is the partial solar eclipse, which is a solar eclipse in which the moon does not completely cover the sun. It may cover only a portion of it, a large portion of it. So the top may be sticking out, or the left side may be sticking out, or the right side may be sticking out, or the bottom may be sticking out, but a portion is stuck out. And finally, we have a total solar eclipse, which is another type of solar eclipse. It's a solar eclipse in which the moon completely covers the bright surface of the sun. The annular, partial, and total are the three subtypes of solar eclipses. Now, how does a solar eclipse occur? In this cartoon that we see from your textbook, the Earth is shown on the left side, and the moon is on the middle right. Now, if we were to extend the lines out, we could see that there's the sun in the very right side of the cartoon that we drew in. And since it's not to scale, I'm going to put these little jogs here to indicate that it's not drawn to scale. So you are here on the Earth in this dark region. You're standing in that dark region on the Earth, and you are looking up into the sky, and you see the moon, and it is blocking the sun during a total solar eclipse. The sun stays there in the sky. The moon is actually on its orbital path going around the Earth, and the Earth is rotating in the opposite direction. And what you would see over a few minutes is the entire sun disk in the sky, followed by a few minutes later where you can start to see the moon crossing over the sun disk, followed by a few more minutes later where even more of the sun is being covered by the moon, until finally the entire sun is covered by the moon in a total solar eclipse. And if you're lucky, right when the moon is either passing into or coming out of the total solar eclipse, you'll see what's called a diamond ring effect, because it looks like a diamond ring in the sky. And then the reverse occurs until you finally just see the regular sun in the sky again, the sun disk. So remember the order of objects in a solar eclipse is always Earth, Moon, Sun. Earth, Moon, Sun. Or Sun, Moon, Earth. The moon is always in the middle between the Earth and the sun. So the moon phase has to be a new moon. Now, where on Earth do you need to be to see a solar eclipse? So I placed you on the Earth in the darkest point. But what if I moved you to Florida? What would you see? You would see nothing. You wouldn't see a solar eclipse at all. You would just see the bright sun disk in the sky. And that's because you're not in the umbra region. The umbra is that deep dark region, this shadow region, on that shadows that drops onto the Earth. So you need to be in that shadow region, in that little tiny circle spot, to get to see the total solar eclipse. Now, if instead you were in this penumbra region, then you would see a partial solar eclipse. To see the total solar eclipse, you must be somewhere along this total eclipse path. Let's say your flight was delayed and you were only somewhere in this region where you landed in your plane and you didn't have enough time to actually drive into the region of the path of the total eclipse. Then you would be in this region called the penumbra region, and you would see a partial solar eclipse. So remember, this dark region is the shadow cast by the moon on the Earth, and that would be where your umbra is located, and the region where you need to be on the Earth to see a total solar eclipse. If you were instead in this region, or this region that casts a shadow to make this annulus on the surface of the Earth, then you are in the penumbra region, and you will only see a partial solar eclipse. If you are located in the ocean, or you are located in Easter Island, or if you're in Africa, you're not in the umbra, you're not in the penumbra, you will see no eclipse.